Well, welcome. Thank you so much for coming. I know there's a lot of great talks out there, and I appreciate you taking the time to come to see this one and that. I hope that you enjoy it. The title is People's Behavior Predictable? And it really comes out of a number of talks that I've been doing. Last year I did a talk at ICTCM, an earlier presentation, and what that presentation had to do with is it concentrated kind of on the amazing impact of mathematics and the natural sciences. And there's a tendency for students and people to understand very well that you need to know mathematics and the natural sciences. If you're going to be a physicist, you need to know math. But if I'm going to go into the social sciences, do I need to know math? And it illustrated really, the last talk, how we are interpreting the world more and more in terms of mathematics. So there's like the Large Hadron Collider, that's one of those atom smashers that they're building in Europe. And it's the little circle there is 27 kilometers around, and it's under 100 meters underground. And they're trying to accelerate these particles and do a lot of strange things with them. And why are they building it? Well, it goes back to mathematics, and in one word, it's something called Higgs, is why they're building this. And the Higgs particle is important because, like when you're riding in a car and you step on the accelerator and you get pushed back into the seat, there isn't really a good explanation why that happens. And they think it's the Higgs particle is the one that's doing it, that there's some particle kind of like gravity, a photon is with light, gravity, a graviton, but what is there for inertia? There should be some particle associated with it. So they're looking for that. Now the interesting thing is there's no real experimental evidence for Higgs, but yet they're spending billions of dollars to try to find it. Okay, so well, what's going on here? Why do they think Higgs exists? Well, it's a symmetry in the equations. And people many times think, at least physicists think, that they believe the equations. They look for simplicity, they look for symmetry, and it looks like everything works better if we have this particle out there. And it's interesting, in 1964, Peter Higgs proposed the Higgs particle in a paper that contained only 79 lines and 5 equations. So, I mean, that's mathematics, and it's so concise in that, and out of this came the theory of the Higgs particle. The other thing they're trying to do is scientists hope to create black holes. Now, I always thought you do not want to make a black hole, right? I mean, that's not something that should be your goal, because black holes have a way of what? Getting bigger and causing trouble and all of this. But evidently they hope to make it, and it created quite a stir in the papers and the people and all of that. Well, what's going on? I mean, and what I always learned is, you know, if there's a black hole that way, then, you know, you kind of get Scotty to get you going fast that way, right? You don't want to be around one of them. So what's the thing that's going on here? Well, the thing that has happened is that what made Stephen Hawking really famous was that he showed mathematically that tiny black holes will disintegrate in a fraction of a second. Okay? Well, what I get out of that is that scientists really trust mathematics, right? I mean, why else would you say I'll make the black hole and I think that I'm okay? I mean, we haven't made one before. And so mathematics plays a really, really big role in the sciences. And this is a very neat paper. Eugene Wigner is a very interesting person, and it's called, his paper written in 1960, The Unreasonable Effectiveness of Mathematics and the Natural Sciences. It's almost a mystery as to why does what goes on in here that people can do with blackboards and chalk, why does what goes on in the mind, at least in Western culture, have anything to do with what is out there as far as what we call reality? Why does mathematics work? And one of the things he brings up is like the complex number I. Well, you know, we as mathematicians, it was kind of formed to solve a polynomial equation that didn't have solutions, right? But somehow I started showing up. Einstein used it. Quantum mechanics started using it, and airflows and airplane wings, and now your kids, when they go into electricity, they use it, and all of a sudden it's being used for something when it's the square root of a -1, That was kind of like, well, we don't need that. That's not very real. But that happens. And another one here, mathematics guides us. Mathematics can lead us in a direction that we would not take if we only followed up the physical ideas themselves. And this is really an important concept, is that sometimes the equations come first, then the reality. And what this came from here is he had the equations for antimatter. 4 years later, they found it. And what you look for is often what you find. And mathematics many times is starting to tell us what to look for.